Hello everybody, I will start my today's another live coding session. So in my today's session, I will solve a question, cracking the safe. Yeah. And I posted this video a month ago. Yeah. And I used the algorithm Euclidean circuit for this question. Yeah, it was quite hard and it actually took a few hours to prepare and understand the solution, even after reading the tutorial. Yeah. And that being said, let me get started. So, in this question, there is a safe protected by a password. And the password is a sequence of n digit where each digit can be in the range 0 to k minus 1. The safe has a peculiar way of checking the password. When you enter it in a sequence, it checks the most recent n digit that were entered each time you type a digit. Okay, so in this safe, the password is length n, fixed number of digits. And it can be, yeah, each digit is from 0 to k minus 1. Yeah, one of those digits. And this safe has a peculiar way of checking the password. Yep. So the password length is n, and when I enter the sequence, it checks the most recent n digit. Yeah. It displays the password length and check if it matches the password. Okay. And return any string of minimum lengths that will unlock the safe at some point of entering it. So I will think of the string, and if it includes, yeah, actually, if it includes, password somewhere, it can unlock the safe, and I will return the minimum one. Oh, and obviously, the password should be the suffix. No, it doesn't mean that. So it means that I don't know which one is the password. So whichever the password is, the string has to unlock the safe. Yeah. So which means that I will think of this minimum length of the string, which includes all the possible password as the substrings. Okay, that's what this question means. So I will take a look at an example, like okay, so quickly, but before thinking of the examples, I will quickly confirm the input and output of this question. So the input should be n and k. Both of them are integers. And n represents the length of the password, and k represents the, digit range 0 to 1 if k is 2. And as I can see from the constraint, n is at least 1, k is at least 1. Yeah, good. And my output should be the string, minimum string possible. Okay, good. So I will think of this question with some examples. So for example, if n is 2 and k is 2, so k is 2 means that the digit can be 0 or 1. Yep. So I can think the password can be 00 or 01 or 10 or 11. So the string I'm looking for has to include all of them as a substrings. So let me think. Maybe I can do it in this way. Like this. So in this case, length is 5. Yeah. And also, as the answer shows, in example 2, 11001 and 01100. Yeah. Both of them include every possible password. So in either way, the minimum length is 5, so I will return any of them. Okay, so this is it. Okay, so I've understood what I would do in this question from examples. So let me think of the algorithm. Okay, so the first, brute force approach I've just come up with is that I will think of every possible password and I will sort them, you know, in every possible permutation. Then I will compact them. For example, if the password is sorted like 00 and then 01, I can compact into 01. Yeah. So in that way, I will try to, compact the password. Then all of those possible, strings, I will return the shortest one. Okay, that's the brute force approach, but I have to solve this question in a more optimized way. So let me tell you how I can solve this question. Okay, so let me use Miro, the free board, in my today's session. Okay, so let me think of this case and let me tell you how I can think of this in a more optimized way. The first thing I will say is I will think of every possible password as a node. So it goes like this. Okay. So for 00, oh, wait a minute. Okay, so now I'm ready. So let me get started. So firstly, let's think I have. Oh, wait. Yeah. Oh, wait. Okay, so when I have 00011011 password, let me write it in this way. And let me think. Say I will start from some node, say like 01. And if I try to move to say 01 them, oh, sorry. So if I try to move from 01 to say oh, sorry. Okay. So let's think I move from 01, then I go to this node and this node and then this node. So in this case, the um, string of this path represent 01100. Yeah. For this, actually, it seems like this is 01, then 11, then 10, and 00. But I can compact this, yeah, into 011 or 110 and 100 part. So in that way, this represent 0111, oh, 01100. Yeah. So what I meant to say is that I will try to find a path which goes through all of them. And then I will think how much I can compact it. Then I will return the length. Yeah. Okay. That being said, one thing I'm wondering is if I move from 01 to say 00, this means that the length of the string is +2. But if I move from 01 to 11, the length of the string would be +1. Yeah, or this one +1. Because this shares 01 and 11. Yeah. So the thing I'm wondering is, if I keep choosing only +1 paths, that's great because I don't waste. I mean, I can duplicate the password as much as possible, which means that I don't lose, you know, I don't waste the characters. So that being said, I would think if I can always choose +1 until the goal. Yeah. So let me write only +1 path. This is +1 path. Oh, 0, 1, then 1, 0. Yeah. 1, 1 to 1, 0 only. Yeah. Then 1, 0 to starting from 0. So yes. And 0, 0 to 0, 1. Yeah, like this. Okay, so yeah. Okay. So one thing I can find from this is, so for this 0, 1 including path and no, so including edge and I mean, sorry, there is one injecting edge and there's one outgoing edge. Yeah. And for this 1, 1, the same. There is one incoming edge and one outgoing edge. And for 1, 0 and 0, 1, there are two incoming edges and two outgoing edges. Yep. So that being said, I would take a look how many paths incoming. I would take a look at the in degree and the degree of each node. So 0 n digit, and for incoming, this is exactly number of digit it can come here. And for out degrees, this is exactly how many digits can be here. Yeah. So that's the in degree and then degree. So in case of 0, 0, 0 can come here. Well, 0 cannot come here because if I take 0, that I duplicate the same number twice, 0, 0 and 0, 0. But for 1, yes, this is possible. So yeah. That being said, let me think how many can be here. So as I said, basically there can be n digit, but I have to think of the case when this digit is equal to this digit, because in that case, you know, I cannot take that digit. So what I can say from here is that if this digit is equal to this digit, the first one digit is equal to this digit. The second one is equal to this digit. So all the digits are the same. So in that case, I cannot choose that digit here, just like 0, 0. And same for here, outgoing edges count. If I can basically choose any digit here, but if this digit and this digit are the same, that number should not come here. Yeah. So again, that is the case when all the digits are the same. So this means that in degree is equal to out degree all the time. Okay, so that being said, I can say something. So this is actually, I can find the Euclidean. I can find the Euclid circuit. Let me tell you why and what it is. So Euclidean circuit, circuit is something like I can visit every path, not the node, but every path without going through the same path twice. All of the paths can be visited once by starting from some node until some node. So that's the circuit, path of circuit node. And let me think in which case it becomes a Euclidean circuit. If I start from here, if I can go to any path, I don't know how it goes through. But in the end, it ends with this. So you can see for each node is in degrees is equal to out degree, except for start node and end node. In this case, this is a Euclid circuit. Or if this goes back to here, in this case, for all the nodes, in degree is equal to out degree. Yeah. So that's the case when it becomes the Euclidean circuit, which means that I can visit every path only once from some node to end node. And in this case, as I shown, for each node, in degree is always equal to the out degree. And so this means that this is the Euclidean circuit, which begins from some node and ends with that node. Yep. So that's what I can say from this first. Oh, wait. So there's one mistake. Yeah, I checked my note and I noticed the mistake. So I said in degree, out degree or something, but actually, when this graph is given, oh no, sorry, it's correct because this is a directed graph. Okay, sorry, just forget. Good. Okay, so let me think of the algorithm, how I can visit each node. So, first three, I can say I can start from any node. Even from 1, 1 is possible, 1, 0 is possible. But I will come back there. Okay, so when I think of this again, let's say I start from some node, say from here. Then let me think. I start from here, then visit here, then I have two choices. Let's say I choose here, then I choose here. Yep. So I will think of this as a graph question, and I did the DFS. So what happens now? So what happens is that the number looks like this. Yes. However, as I can see, no, 1, 0, 0, yeah. 0, 0 appears twice. Oh, wait, what am I doing? Oh, so actually, I don't have to come back here. So this one is actually, oh, sorry. So, I mean, I start from here and 0, 0, 0, 1, 1, 0, and then 0, 0. But I can just forget the last 0, 0. And by for getting it, the string looks like this. However, in this case, 1 is missed. So I have to somehow include it. So let's say how I can traverse this graph without missing 11. So what I can do in this case is, say I start from here, then let's say, wait a minute. Okay, I start from here, and go here, and go here. And if I reach the goal, I come back. And I try to go to another path. And then I will keep going. And then, oh, sorry, I actually can't go this direction. So, sorry, go from here to here, then here, then here. And when I come back here, I will go back. And I will think of other ways I can visit. Yeah, I can find 1, 0 to 0, 1, but I don't take it because 0, 1 is already visited. So I go back again. And now I find there is 0, 1 to 1, 1 path. I go that. Then after that, I will take a look and I find that 1, 0, but 1 is 0. No. And 1, 0 is worth visiting because I have not visited yet. Oh, wait. So let me, sorry, think of this again. So what I've noticed is that actually I have to visit every path, not every node. I try to remember that. So let's say I come here first. Then because I came back to the node, original node, and there isn't any path I can go from here. So I try to come back. Then I notice that there is one path I can visit. So I visit this way. Then after that, I will take a look at every possible path I can visit. And I find that there is a path here. And I will try to visit. Then there is no any other path, so I come back. And here, I find that there is no any other path I haven't visited, so I come back again. Yep. Then I come back in this way. I finally come back. So what I did currently is I try to visit every path if there is a path which I haven't visited. And if there is a dead end, I will come back. For example, if I go 0, 0, 0, 1, 1, 0, and then 0, 0, I don't have any of the paths which I haven't visited from 0, 0. So I backtrack to 1, 0. Then I find that 1, 0 to 0, 1 is not visited yet. So I visit that. Then from there, 0, 1 to 1, 1 is not yet. So I try and I go. And then 1, 1, 1, 0 hasn't been visited. So I go. Then I come back. Yeah. And keep going back. So in that way, let me tell you which path I took. So from 0, 0, I went to 0, 1, then 1, 0, and 0, 0. Then that's the dead end. So I come back. And from here, I visit 1, 0 to 0, 1. Then I visit 0, 1 to 1, 1. Oh, no, sorry. I'm telling wrong. I actually have to do the DFS on node, not the path. Sorry. Because each node represents each password. So my goal is to visit every node, not every path. So let me think of this again. With that being said, So from here, I visit here, and I visit 01, and visit here, and visit here. Then I go back, and then I find 11, which is not visit, so I visit there. And after that, I find that I visited all the nodes. Oh, actually no, because I've already visited 00. So from here to here, I don't visit 00 anymore. Yeah. So I visit here. Then I go back. I see. So yeah. Okay. So actually, even though I can find the circuit, I don't take the last pass because it is not necessary. I don't have to visit the final pass, final node, start node again. So I can forget it. But with that being said, I can find the path which I visit every node. Yeah. Okay. So that basically is the algorithm. So I start from some node and I use DFS and try to visit node that I haven't visited yet. Yeah. And if, okay, let me say, yeah, so yes, so this case is quite simple. But let's say I reach the dead end. I don't know if this exists or not. Okay, this is a good example, I think. So in this case, I start from here, then I did here, 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 here. And I find that this is a dead end because I cannot visit here. I don't have to visit here, but there's no other path aside from that. In that case, I still have this node. So I have to go back here. Then I try to visit this one. Yeah. So simply I can use the DFS. The order of the node I will visit is 1, 2, 3, 4, 5, then 6, 7. Yeah. However, one thing I have to take care is that I, you know, I have to take care that if I take this password in this order, there isn't what I want because there is jump from 5 to 6. What I actually want to know is this order: 1, 2, 3, 4, 5, 6, 7. Yep. So how can I get this order? So one thing definitely I can do is okay. I count the node when I leave the node. Yep. So instead of this one, red one, I will visit it in this order. So firstly, when I reach 7, because I visit, this should be number 1. Then after come here, I read this one, so that this is 2. And here, because before reading this, I will go to this path. I will go here, then here. And when I reach this node, there isn't any other path. So that's the end. This should be number 3, 4, 5. Now this becomes 5 because I will read. Because I've already visited every path, I can go from here. Then 6 and 7. Okay. And now what I can do is, if I reverse these purple numbers, it becomes the red number. Yeah. So this is exactly what I can do to find this Euclidean circuit. Okay. So I can say this is the pulse of the traversal because I counted when I read. So when I think of the tree, when I do the pulse of the traversal, it is counted like. So basically, if there is something like this, it should be considered 1, 2, 3 this order. So 1, 2, 3, 4, 5, 6, 7. Yep. So samely in this counting way, I counted it exactly when I reached the node, assuming that I visit 1, 2, 3, then 4 or something like in DFS. Okay, so that's the basic idea I can use in this question. Okay, so that being said, I will start the implementation. So let me use recursion for this DFS. Oh, this is the current password. And also because I have to take care of the visited node, because if I once visit some node, I have to mark it as visited and I don't have to visit it anymore. Yeah, that being said, in this question, the length of the password is quite short, like 3 characters. So I will assume it is the constant length. Yeah. So I will just keep track of the, I mean, when I try to find the next password, I will try to, generate another string from the last and minus 1 digit. And I will assume that that takes the constant cost. So this is a visited password. And let's say I will choose. Okay, let me say this is a start word. Oh, no, wait a minute. So, okay. Oh, I can do it in this way. No, because I will guess the node in the reverse order. So if I put it in the head, So it doesn't work. So let me just start with empty. And then let me say this is reverse chars. And I will start from the first password, and this should be already counted in the visited set. Then I call the visit method. Then the last thing I will do is reverse chars. I will reverse this. Then I will return this. Okay, this is exactly what I will do. So that being said, let me get started. So in line 20, what I will do is I will take a look at every possible next char. Then I will generate the next password. Oh, by the way, what I have to take care is once I visit this node, I have to mark this as noted, visited. This way. So if next password is already visited, I will skip it. But if not visited, I will visit it. Yes. So this is how I visit every node recursively, yeah, in DFS. And as I said, if I find the new password here, which means that this next char is worth visiting, I don't append it now. So let me show you an example game. In this case, even if I visit this, I still don't mark this as visited. So yeah, let me take a look at this node. Yeah, I came here, but not yet marked as visited. But I could visit this, and come back, and then go here. Then after going to every possible path, or I should say every possible adjacent node, I mark this as visited with this number. No, sorry, not marked, but I will choose this char, or I should say password. Yeah, so that's what I have to take care. So I will do that here. And this should be the last char in the password. Please remember that, say in this case, if I go from here to here, the last, firstly I choose 0, 0, and when I visit 0, 1, the character I will choose would be only one. Only one is appended to 0, 0. Yep. So that's what I will take care. Oh, by the way, even for this start node, the Rust char is added with this implementation. So in line 42, I just have to skip that Rust character. This is it. Okay. Now let me execute my code. Good, accepted. So I submit my code again. Okay, accepted. Wow, surprised that I could have this question in one shot. Okay, so now time complexity. So for this, I visited every possible password with only one character appending. And I didn't visit any node more than once, but definitely I had to check every, possible pass from every node. So I can say in the graph perspective, the time complexity should be O of B plus E. Yep. Other operations like reversing or joining or concatenating takes O of V, because V is exactly the length of the password we will generate. And yep, so those operations takes up to, or just exactly length of the path. Sorry, length of the, how should I say, string I will return. So O of V plus E. And in this question, I have to think V and E. So V is exactly the number password. So, sorry. Yes. Yeah. Every possible password. So it should be n to the power of n. No. K to the power of n. And for E, from each node, I have, the every possible path, which, yeah. So I will take a look at this example again. When I take a look at this password, the next password is this, and I checked every possible character here, yeah, which is exactly the number of edges, which is outgoing from the current password node. So it should be okay. Yeah. So the time compressed should be this, which is k to the power of n. Good. And for space complexity, I did the DFS. And in the worst case, the length of the recursion stack is exactly the length of the every possible password. So it should be over k to the power of n. And aside from that, I created reverse chars, which is again k to the power of n. And visitor said this is the same. Oh, I actually didn't assume that. I assume that n is the constant. Yeah. So yeah, but actually, if I use n as the power, it can be ignored. It cannot be ignored. But if I use it as just a coefficient, like k times n, it can be more, I can say, ignorable. Yeah, but let me be more strict on this. Oh no, sorry. Let me just be a bit loose on this. It should be k times n for reverse chars. Yep. So this should be k to the power of n. Yep. Wait. So this should be this. So if I take it as k times n, k times yeah, I can just say the time compressed is like this. And I'm pretty sure k to the power of n is basically larger than k to the power of n in many cases, but it's not strictly, yeah, I think I can just read it in this way. Okay, good. So let me quickly wrap up my today's coding practice. So in this today's live session, I solved the question, cracking the safe. So this is a question in which I'm given the, I will think of the password whose ranks is n, and each digit can be 0 to k minus 1. I have to find the string which includes all the possible password as the substrings, and I've written the shortest one of such a string. Yep. And as in my solution, I use the Euclidean circuit. Or I should say, I noticed that okay, I first retook this question as a graph question, and when I visualize it with node and edges, I find that I could rephrase this question as I will visit every node from any node I can start from. And then I noticed that I can, I can draw the line in a Euclidean circuit way, and I find that that is the best shortest string I will generate. So I use postal traversal on this graph in DFS, and then I generate the string and I return it. Okay, so that being said, let me finish my live coding session with this. Thank you so much. Bye.